Hi everybody, welcome to goal number 4. In this one we're going to be solving radical equations. So you'll notice in each one of these equations that there's a radical sign, radical meaning a square root. How do we solve these problems? Believe it or not, these are actually pretty quick and easy to do. Remember though, inverse of square, that's the inverse operation or opposite operation of squaring something, is to do the square root. And that goes both ways. So if we have a square root in the problem, the inverse operation would be to square. With that in mind, take a look at a problem like this first one here. Square root of x equals 3. What this is saying is ultimately square root of what number is equal to 3? You could probably do that one mentally and know that the answer is going to be 9. How do we do that? Well, the inverse of square root is to square both sides. The square and the square root will cancel each other, leaving with just an x. And 3 squared is simply equal to 9. So that means that my answer is equal to 9. It was that quick and easy. If I took a 9 and put in square root of 9 equals 3, tested it, it works out perfectly. Okay. Take a look at the second one here. Not much different. The square root is isolated, meaning there's nothing in front of it and nothing outside of it to the right. So if we square both sides, we end up with x minus 2 is equal to 25. And if we solve this, we get x is equal to 27. Again, let's test our answer. Take 27 and put in, we have 27 minus 2, which is 25. Square root of 25 is just 5, so that works. Third example here, 3 times the quantity square root of x plus 2 minus 4 is equal to 11. So we have to isolate our square root before we can actually square both sides, which means we're going to have to add 4 and divide by 3. So when we do this, we end up with square root of x plus 2 is equal to 11 plus 4, which is 15, divided by 3, which is 5. Square both sides. The square and the square root will cancel, leaving with just an x plus 2 is equal to 25. Subtract 2, we get x is equal to 23. Again, let's test this though. If we take and put it in, we end up with 3 times the quantity square root of 23 plus 2 minus 4. So this is 23 plus 2, which is 25. Square root of 25 is 5. 3 times 5 is 15, and 15 minus 4 does equal 11, so it checks out. Now let's look at this problem over here, where we have square root of negative 10 plus 7p. Sorry, this got carried over a little too far, so it's not there. The square root is just over the negative 10 plus 7p, and that equals p. My square root is isolated, so let's square both sides. And what will happen is we're left with negative 10 plus 7p equals p squared. Now this one's a little different because now you'll see that it relates to our unit where we have a quadratic here and we have to try to solve it. So if we move everything over to keep p squared positive, we're going to take these two and move them to the right, which means we'll add 10 and subtract 7p. So if 0 equals p squared minus 7p and plus 10. It's a trinomial, leading coefficient 1. There's no GCF, so let's just factor this. We end up with p minus 2 and p minus 5. Again, those are the factors of 10 that will add up to negative 7. That means that we get p is equal to 2 and p is equal to 5. Now, it is important that we test these. All right, so let's take each one of these and test them out. Negative 10 plus 7 times 2. So that's going to give me negative 10 plus 7 times 2, which is 14, and that equals 2, because that's our p-value is 2. So negative 10 plus 14 is 4. Square root of 4 is 4 is 2. So that checks out. Let's try the 5 here. Negative 10 plus 7 times 5. So negative 10 plus 7 times 5 equals 5. Again, that's our p-value. Negative 10 plus 35 is square root of 25, and that does in fact equal 5. So it checks out. All right. Go on to this fifth example. Square root of 2v minus 7 equals v minus 3. The square root is isolated, so let's square both sides. Now this you have to be careful. We have to square the whole binomial. General thoughts of people are that they just square each part and they'd say v squared and positive 9. But that's not true. Think of it like this. If I have 2 plus 3 equals 5, and I decide to square it, I can't square every part. Watch what happens. I end up with 4 plus 9. Does that equal 25? It certainly does not. So what we're supposed to do is actually, when we're doing these, is group this together and then square it. And so what's going to happen when we do that is we're going to have to take and follow our process of doing a binomial squared with perfect square trinomial. So we'll have v squared. We'll have a positive 9. So that's our a squared, our b squared. And then do a times b, double it. So v times negative 3 is negative 3v. Double it is negative 6v. Okay? Let's move everything over so it's equal to 0. So we have 0 equals v squared minus 8v plus 16. It's trinomial leading coefficient of 1. So we got v minus 4 and v minus 4, which means that v is equal to 4 in this problem. Check it out. 2 times 4 is 8. 8 minus 7 is 1. Square root of 1 is 1. So if we put a 4 over here, 4 minus 3 is going to equal 1. So it does check out. Next example. And this one, I think, if I remember right, is a little bit of a doozy. So let's make a star here so you remember it. When we see a 1/2 power, 1/2 power is the same as saying square root. So I can actually rewrite this as a square root and just get rid of the half. So now we're going to treat it like every other problem we've done. Square both sides. We end up with 20 minus r equals r squared. Let's get everything equal to 0. So we have 0 equals r squared plus r minus 20. It is a trinomial with leading coefficient of 1. So we have r plus 5 and r minus 4. Because 5 minus 4 is 1, and 5 times negative 4 is negative 20. Solve for each, we get r equals negative 5. And solve here, we get r equals 4. Now let's test these answers. Let's try positive 4 first. When we do the square root of 20 minus 4, does it equal 4? Well, 20 minus 4 is 16, and the square root of 16 is 4. So that actually checks out. So this is definitely an answer. What about when we use negative 5? Square root of 20 minus negative 5 equals negative 5. This is a square root of 25. The square root of 25 does not equal negative 5. And so what happens is this answer right here does not work. We call this an extraneous solution. It's a solution that we were able to arrive at through our methods, but it's a solution that doesn't actually work. So what we're going to do is we're going to circle it so that we know that it was one of our answers, and then we're just going to cross it out saying it's an extraneous solution. So again, it was a problem that or is an answer that we got from doing our normal steps of solving, but when we check it, it doesn't actually work. So unfortunately with these, you are supposed to keep checking them to see if there's any extraneous solutions. Let's try the next one. We have 2 square roots in this problem. So again, square both sides. We end up with x plus 2 equals 4x plus 3. Just simply solve, we get negative 1 equals 3x. And let's finish solving, we get negative 1 over 3 equals x. Okay. Go ahead and check it. You get negative 1/3 plus 2, which is going to be, let's see, 1 2/3. And over here we do negative 1/3 times 4. That's negative 4/3 plus 3 is 1 2/3. So that actually checks out as well. Last one here. Go ahead and solve this. Let's square both sides. We end up with x plus 6 equals x minus 6. If we work through and try to solve, move the x over, we end up with 6 equals negative 6. So all my x is canceled. So what that means is that there is no solution for this problem. And that should make sense because it doesn't matter what value I put in for x. If I add 6 to it and I take away 6 for it, these would never end up being equal to each other. So there would be no solution for this. I hope this helps. Again, see me for help during the seminar if you need further help, and we will talk to you soon. Take care.